Hello students, welcome to my channel Agricultural Engineering Online with continuation of video lecture series on soil and water conservation engineering. In this lecture, we will discuss about the different soil basic properties and their relationship on the context of soil mechanics. So basically the soil for engineering. In general term, soil is a complex material produced by weathering of solid rocks and continuous geologic cycle. Soil is also a combination of minerals and organic elements that are in solid, gaseous and aqueous form. Soil consists of particles layers that are different from the original materials in their physical, mineralogical and chemical properties because of the interaction between the atmosphere and hydrosphere and other regions. So basically, in the context of soil engineering or soil mechanics, we need to study the different properties of the soil in engineering point of view to design functional requirement in construction of different structures, the pavement design for roads and other things, because the seepage, the specific gravity, moisture content, the softness, other things, the soil properties needs to be known before designing the pavement or roads. Also designing of underground structure needs a lot of engineering study of the peripheral soil. Before designing, all the properties has to be carefully studied. Then earth retaining structure, also the soil properties are very important. Embankment and excavations, we need to know how much the soil unit weight, the porosity and other things, so that it can be easily done in engineering point of view. Design of earthen dams also needs to study different properties of the soil properly before designing. So in this chapter, mostly we will discuss about the density related, porosity and other things, how they are interrelated with each other, with water content, the specific water content, the you can say apparent unit weight, other things. In SI unit, the density is mass per volume. So in gram per centimeter cube or kg per meter cube, it is used in general, and sometimes unit weight is used, that is kilonewton per meter cube instead of kg per meter cube. So you can multiply by g. So instead of kg, you can find out kilonewton. In also pressure are very important. The pressure is also calculated as in the unit of kilonewton per meter square or kilopascal. So straightforward, let us go to the different properties of the soil which will be required in the case of soil mechanics later on. First of the different fundamental properties. So let us say this is the soil. So already we discussed soil is a combination of different elements, that is in solid or liquid or gaseous state. So if this is the total soil and V is the total volume of the soil, this is the V, and in this soil there are two parts, one is the solids and the other one is the void, you can say. So let us VV is the volume of voids and Vs is the volume of solids. So this is Vv and Vs. Vv is this one and Vs is the volume of solids. So therefore the total volume of the soil will be equal to volume of voids plus volume of solids. But the volume of void can be again classified into two states, one is the air and other is the water. So therefore this void can be again divided in two parts, volume of air VV, VA and volume of water, that is VW, let it be. So therefore the total volume of void will be equal to Va plus Vw. Next, coming to the weight. Let us say this is the weight of air. There is the volume of air contains weight. So in this case, the air weight is 0 because we can consider the air, the system is in an open system. So therefore there is no weight by the air exerted on the soil. And the rest is the of the void. Let us say the water, weight of the water, which is the volume of water Vw having a weight, that is this one, so W. Okay, so this is the weight of the water. So rest is the volume weight of the solid, which is the volume of the solid Vs. So Ws is the weight of the solid. So these are the, and weight of the volume void will be equal to weight of the water, since the weight of the air is equal to 0. So therefore, so this is weight of the void, which is equal to weight of the water. So total weight of the soil will be equal to weight of the water plus weight of the solid. Now let us consider the bulk unit weight of or moist unit weight. So which is the unit weight, or in this case you can say density also. So density, already I told you, density is mass per volume, and unit weight is the force per volume. So force per volume. So this is only the difference. So in this case, unit weight we are taking. So the density, or you can say bulk density or bulk unit weight. In this case, we will have unit weight. So that is gamma will be equal to total weight of the solid soil divided total volume. So that is, in this case, weight we are taking. So therefore weight by volume, that is kilonewton per meter cube. That is the unit of the unit weight, bulk unit weight. See, the bulk means whatever, we are not considering how much water is there or how much air is there. Then dry unit weight, when we remove the water from the soil, only the solids weight, that is the weight of the solids, Ws you can say, and volume is the total volume of the soil. In this case, the gamma D or dry unit weight will be equal to Ws, total weight of the solid, divided by volume. So this is the difference between bulk unit weight and dry unit weight. Dry unit weight will be lower than the bulk unit weight because the weight will be less in the case of dry unit weight. So now next is the unit weight of the soil solids or particles. So here you can say particle unit weight or particle density. Sometimes it is called the particle density. So here particle density, particle means here three forms are there: air, water and solid. So only solid is to be taken into account. Therefore the particle density will be equal to gamma S, or solid you can say. Solid unit weight will be equal to weight of the solid divided by volume of the solid. So this is the only difference between the dry unit weight and solid unit weight. So here actually in the case of total volume, so it is taken as volume of the solid. So volume of the solid will be lesser than the volume of total volume. So therefore the denominator will be less. So therefore the total value will be greater. So therefore the gamma S will be always greater than gamma D. So dry unit weight is always less than the solid unit weight, and also dry unit weight is also less than the bulk unit weight. Next we will say saturated unit weight. Saturated unit weight means there will be no air in the soil. That means all the void space is occupied by water. Therefore gamma or the bulk density you can say, so will be called as gamma saturated. So therefore air will not be there. So therefore then there will be submerged unit weight. Submerged unit weight means therefore will be saturated minus gamma weight. So gamma weight is the weight one, means percentage of void is having water and percentage is air. If all the void is filled with water, then it will be gamma saturated, and submerged will be the difference between the saturated and the weight, unit weight. So therefore in the general case, gamma W is the unit weight of water or bulk unit weight of, in this case gamma W is the weight of water, unit weight of water. So we know that unit of weight of water is 9.81 kiloliter per meter cube. So therefore the submerged weight will be equal to the difference between the saturated minus water unit weight. Then we can convert between the density and unit weight. It's very simple. So there is multiplication of 9.81 and between density and unit weight. So unit weight will be equal to rho into G. So G is 9.81 and rho will be always kg per meter cube. So kg into G is equal to kilonewton, and rho is the density of soil in gram per centimeter cube or kg per meter cube. So then moist specific gravity. So now coming to the specific gravity. So specific gravity is the unit bulk unit weight divided by unit weight of water. So in this case unit weight of water is 9.81 kiloliter per meter cube or Newton per, so there is Newton per centimeter square. So in this case moist specific gravity, so this is the ratio between the unit weight of soil, bulk unit weight divided by unit weight of water. Then true or absolute specific gravity or specific gravity of true density, just like true density will be equal to the solid unit weight divided by unit weight of water. This is the difference between the moist specific gravity and true you can say absolute specific gravity or specific gravity. The difference is, instead of this is bulk unit weight, this is solid unit weight. So solid unit weight is always greater than bulk unit weight or dry unit weight, you can say. Then moisture content by weight basis. Moisture content is the moisture content by the soil, which is equal to, let it omega is weight of the water present in the soil. So let us say this is weight of the water in the soil divided by total weight of the water soil into 100. So there is the percentage of moisture content. The moisture content by dry basis, this is weight basis, because W is the total weight of the weight soil. So therefore this is called the weight basis on the weight of the soil moisture content. And moisture content by dry basis means, dry means about the solid, instead of W it will be WH. So therefore the moisture content by dry basis is the total moisture content or weight of the moisture content, moisture in the soil, a particular volume divided by total weight of the solids. So this is the difference between the weight basis moisture content and dry basis moisture content. So therefore the percentage, because WS is less, so therefore the percentage in dry basis will be greater. So therefore this one will be equal to moisture content weight basis. Next coming to moisture content on volume basis. So moisture content on volume basis means volume of water by volume of soil. So therefore we can multiply the moisture content by weight basis into the specific gravity on weight specific gravity, you can say weight specific gravity, then you can find out the moisture content on volume basis. Again moisture content on depth basis, which is actually generally calculated as cm of centimeter of water for 1 meter soil depth, which is basically used in soil water conservation during irrigation of the soil. Then void ratio, coming to the void ratio, how it is calculated? Void ratio is the void to the total soil. So let us say this is the total soil volume, and this is the weight of the volume of the void or the space. This is solid and this is void. So therefore the void ratio will be equal to V is the total volume, and this is volume of void and volume of solid. So therefore the void ratio will be equal to volume of void divided by volume of solid, which is expressed in fraction. Remember, this is, there is no unit, only fraction. Next, let us say this is the void ratio. Let us say this is void ratio and this is 1. 1 is to E. 1 is the solid. So therefore this is 1 and this is E will be equal to VB. So if Vs is taken as 1, then the void ratio is E, or the fraction will be E, or fraction of volume of 1. Then porosity can be calculated, which is equal to volume of void divided by total volume into 100. So total volume is, in this case, E plus 1. E is the void and 1 is the solid. Therefore 1 plus E is the total volume of the soil. So therefore putting V is equal to 1 plus E and volume of void is E, already defined. So therefore we can have a relationship between the porosity and void ratio, that is N will be equal to E by 1 plus E, or void ratio divided by 1 plus void ratio into 100. This is the porosity. Porosity is generally in percentage, the unit will be in percentage, and void ratio is in fraction. So now if you see again, interrelate, let us, 1 is the total volume of the soil, and N is the void, which is the porosity, and 1 minus N, rest 1 minus N is the volume of solid. Therefore the degree of saturation can be calculated on the case of S. So S will be equal to volume of water divided by volume of void into 100. So volume of water by volume of void, how much percent water is present in the void, that is called the degree of saturation. So in the case of saturated soil or fully saturated soil, volume of water will be equal to volume of void, which in turn we can say S is equal to 1, or the degree of saturation is 100% or 1. For fully dry soil, there will be no water, so VW will be equal to 0, so S will be equal to 0. The degree of saturation will be 0%, or in whole term there is 0. Next, there are different relationship between the different properties. So let us, the degree of saturation and you can say the void ratio. So if you multiply degree of saturation and void ratio, so will be equal to the, this is moisture content in weight basis into specific gravity. So this is a simple relationship you should remember. From there, dry density can be calculated, so or dry unit weight can be calculated as bulk unit weight divided by 1 plus moisture content by weight basis. Remember, this is the relationship between the dry density and bulk density also. So because the unit weight and density are interrelated with G. Then also the reverse, the unit weight, bulk unit weight can be again calculated from the specific gravity plus the degree of saturation into void ratio, and also unit weight of water divided by 1 plus E is the porosity. For fully saturated soil, the degree of saturation is 1, and the bulk unit weight will be equal to saturated unit weight, and saturated unit weight can be calculated from this formula, that is G plus E. The G is the specific gravity plus E into unit weight of water divided by 1 plus E. Again, so from this, so it is calculated because gamma is gamma saturated. So this one S is equal to 1, then this is calculated. For fully dry soil, the saturation point will be 0, so therefore gamma will be equal to gamma D. So in this case, the gamma D can be calculated as G into gamma over W divided by 1 plus E. Submerged unit weight, so when the soil is basically sand and other things, when it is submerged in water, the submerged unit weight can be calculated, which is the difference between the saturated unit weight minus unit weight of water, and gamma submerged weight will be equal to gamma saturated minus gamma weight, that will be equal to, if you see, gamma saturated is here, G plus E gamma W by 1 plus E minus gamma W, or which you can say submerged unit weight will be equal to G minus 1. In this case, G instead of G plus E, this is G minus 1 and 1 plus E will be there and gamma W will be there. So this is a different relationship between the different fundamental properties of the soil. Hope you understand. Please like and subscribe to my